Now, picking up where we left off, our common denominators were 21. Now, we have 3 and 15 over 21 plus 4 and 14 over 21. So we add our fractions. That would give us 29 over 21. And then 3 plus 4 is 7. Now, if you look here, you notice we have an improper fraction here. So what we need to do is to write this as a mixed number. Let's concentrate on the fraction. So we would take 21 into 29. 21 goes into 29 one time. 1 times 21 is 21. 29 minus 21 is 8. And we have a remainder of 8. So our mixed number here would be 8 over 21. Now, actually, this is what happens. This becomes this here. And all we have to do here is add the integers together. 7 plus 1 is 8, and we'll bring down our fractions. So it's 8 and 8 over 21. Now we go here to number 4. Let me draw this line to show that this goes only with number 3. Okay, number 4, we have a negative 86 and 5/8 minus 49 and 7/10. Since both of them have the same sign, we know we're going to add them together and carry the sign. So our final answer is going to be a negative. So we could write this vertically. We will have 86 and 5/8, or we could put negative 86 and 5/8 minus 49 and 7/10. Now I'm going to do this a little differently than I did the other problems because I didn't give myself enough space. Okay, now what we need to do is this. We need to find a common denominator. So we will have our 8 and we will have our 10. 8, in previous problems we found out that the prime factorization of 8 is 2 times 2 times 2. The prime factorization of 10 is 2 and 5. Now, what we look at here is we have one set of 2's that match up. So we have our 2, and we bring down these other 2's and this 5. 2 times 2 times 2 is 8, times 5 is 40. So our common denominator here is 40. So we have put, actually, I should not have put these equal signs here. So let me erase that real quick. Now, I got rid of the equal signs. Now, what I was supposed to do here is this here. Our common denominator is 40. But before we do our common denominators, what I want to do is, let's compare the 8 to the 10. We ask ourselves, what does 10 have that 8 does not? And that is 5. So we'll multiply our numerator and denominator by 5. Now down here, we'll compare the 10 to the 8. What does 8 have that 10 does not? 8 has 2 extra 2's that 10 does not. So we'll multiply our numerator and denominator by 4. Now we can put our equal signs. This will make it a little easier. So it'll be a negative 86 minus 49. And now we do our fraction. Our denominator is 40 here. 8 times 5 is 40, like our least common denominator here. And 5 times 5 is 25. Now, 10 times 4 is 40. And 7 times 4 is 28. Now, there's a little problem here. This is the first fraction we've encountered where we have the bottom fraction here larger than the top fraction here. Now, if this was a regular subtraction problem, we would have to borrow. However, remember, since both of these have the same sign, we're going to add them. So this really doesn't matter. So we can add these two fractions. 25 over 40 plus 28 over 40 is 53 over 40. And we add 86 and 49. 6 and 9 is 15. Carry our 1. 8 and 4 is 12. Plus 1 is 13. So it'll be 135 53/40ths, and it's negative. Now we know 53 is larger than 40, so this is an improper fraction. So what we have to do is this. We need to go off to the side, and we would take 40 into 53. 40 goes into 53 one time. And we have a remainder of 13. So what we have to do is this here. This is the same thing as negative 135 minus 1, and the denominator stays 40 and our numerator stays 13 because of the remainder. So negative 135 minus 1 and 13 over 40 is a negative 136 13/40. Now remember, what you could do to remember this is this here. Whatever this integer is, you will add it on to this number here, and the fraction will remain the same. So since our integer here was 1, we'll put it together with the 135. That will give us the negative 136, and our fraction 13 over 40 stays the same. Okay, now we need to scroll down. Now we come to number 5. Number 5, we had 8 1/6 minus 3 3/4. Now we need to find a common denominator. So we'll take 6 and 4. 6 becomes 2 times 3, and 4 becomes 2 times 2. Now, what we have here, we have 2 and 3, and we also have 2 and 2. Now, to build our least common denominator, we match up these 2's here. We count it once. We have 1 2 left over, and also a 3. And now, our least common denominator would be 12. So, what we do is this. We do comparison. What does 4 have that 6 does not? It has an extra 2. So we multiply the numerator and the denominator by 2. Then we compare the 4 to the 6. What does 6 has that 4 does not? It has a 3. So we multiply the numerator and denominator by 3. Now, this would give us, we'll still carry over our integer. This would be 8. Our denominator would be 12. And our numerator would be 2 here. Now we would carry over our minus 3. Our denominator would be 12. And our numerator would be 9. Now in the last problem I talked to you all about how our bottom fraction was larger than our top fraction here. Now this is subtraction. So what we need to do here, we need to do what is called borrowing. Now, when you borrow, there's a simple method of borrowing here. You have to take 1 from this 8 here and make that a 7. So now, we're going to write this 7 over here. Our denominator is still going to stay 12, and we're still going to carry over the minus 3 and the 9/12. Okay, now, what we have to do here is this here. We have to determine what our numerator is going to be. Now, an easy way of how to do the numerator is this here. When you borrow 1 from this 8 and make it 7, you look at the denominator here. The denominator is 12. So, in order for 7 to be 8, this is the same as saying 7 and 12/12. Because this is the one that you borrowed, this 12/12. And you add it to 2 over 12, and that will give you 14/12. Now, if you cannot remember that, there's another way of doing this. You still will borrow 1 from the 8 and make it 7. But to find out your numerator here, you could take the denominator and add the numerator, and that would give you the numerator. Again, you could take the denominator and add the numerator. 12 plus 2 is 14. So now we have 7 and 14/12 minus 3 and 9/12. 7 minus 3 is 4. And 14 minus 9 is 5. And our denominator stays 12. So that is our final answer for problem number 5. Now, for problem number 6, we have a negative 72 2/9 plus 27 2/3. We know we have to subtract. And we know because 72 is larger than 27 that our answer is going to be negative. So we could write this like it's a traditional subtraction problem But we know at the end our answer is going to be negative. Now we need to find a common denominator. So we'll take 9 and 3. 9 breaks up to 3 times 3. Now we have one set of 3's in common and 1 3 left. So our common denominator is 9. So we'll multiply our numerator and denominator. Now we look here. First we compare the 9. We look at 9. What does 3 have that 9 does not? It's nothing. So what we would do is this here. Actually, this 9 should not be here. That was a... Okay, now, like I said before, that 9 shouldn't have been there. So really, since 3 does not have anything that 9 does not, this would be like multiplying by 1 over 1. Now we come down here. We compare 3 with the 9. What does 9 have that 3 does not? It has an extra 3. So we'll multiply that numerator and denominator by 3. So now, we will bring over our 72. 9 times 1 is 9. 2 times 1 is 2. Now we have our minus 27. 3 times 3 is 9. And 2 times 3 is 6. Now we have that same situation here. Our bottom fraction is larger than our top fraction. So what we have to do borrowing. So we know when we borrow here that this will become 71. And like I told you before, your denominator still stays 9, but now your numerator, you could just say 9 plus 2 is 11. So it'll be 71 and 11 over 9 minus 27 and 6 ninths. 11 ninths minus 6 ninths leaves 3 ninths. 71 minus 27 is actually 44. Now 3 ninths can be simplified. So what we would do is we would carry over our 44. Our numerator will have 3. Our denominator will have the prime factorization of 9, which is 3 and 3. These 3 simplify. So you have 44 and 1/3. And that is your answer for number 6. Now we scroll down here to section C, applications. It says Melissa is making costumes for the school play. Each costume would take 1/3 yard of brown fabric and 3/8 yard of red fabric. There are 12 students in the play who will need these costumes. How much fabric of each color should Melissa buy? Okay, now, so what we would need to do is to take 12, because it's 12 students, times 1/3. And then we would have to take 12 times 3/8. So this would be 12 over 1 times 1/3. So we could take the prime factorization of 12, which is 2 2's and a 3, and the prime factorization of 3, which is just 3. These simplify out. So this would be 4 yards for the, what's that? The brown fabric. So 4 yards brown fabric. Okay, now that took care of the brown fabric. Now we're going to come to the red fabric. So we'll take 12 times 3/8, which is 12 over 1 times 3 over 8. Now we take the prime factorization of 12 again, which is 2 2's and a 3, and then times 3. Prime factorization of 8 is 3 2's. These 2's simplify, and you will have 9 over 2. Now this is 9 over 2, which we know if we write as a mixed number, it'll be 4.5, and it'll be yards of the red fabric. So it says how much fabric of each color should Melissa buy? 4 yards of the brown fabric, 4.5 yards of the red fabric. Okay, now it says for B, how much fabric will be used all together? We add these together, 4 plus 4.5, and that will give us 8.5 yards. That's how much fabric that will be used all together.